Hello all. We are looking today at some multiplication and division models. That's 3.4K and 3.5B. So throughout your unit with multiplication and division, you're going to be looking at all these models, and these models are very important. They will either be used to help you solve multiplication division problems, or you'll see these models and you'll need to know how to use them and what to do with them. So the first one is an array. And an array and area model they have a lot in common. They're both made up of rows and columns. So rows go from left to right, just like this, and columns go up and down. Rows are horizontal, and columns go up and down vertically. Horizontal, vertical. An array can be made up of anything. It doesn't have to be made up of circles, even though we usually see it that way, but it can be made of hearts. It can be made of little dogs, cats, smiley faces, whatever you want. An area model is always made up of square units, just like this. When you study area, it's very similar to this. That's why it looks like that. So then we have a strip diagram or part whole model. These can also be called bar models. They're all pretty similar. And the important thing to know is all these parts equal the whole here. So 5 plus 5 plus 5 plus 5 plus 5 will equal 25. Then we have a table. And as you learn, tables can have many patterns and rules. You have your input and your output. And when you study multiplication and division, you'll learn more about tables using the rule to multiply or to divide. Repeated subtraction. So repeated addition. You have repeated addition and repeated subtraction. Repeated addition is when you add the same number over and over. So if you have 3 plus 3 plus 3 plus 3, that would be the same thing as doing 4 times 3 because you have 4 groups of 3. 1, 2, 3, 4. The opposite of that would be repeated subtraction. And it's just what it sounds like. Just like when you use repeated addition, you're adding the same number over and over. With repeated subtraction, you're taking away, you're subtracting the same number over and over. So with 24 divided by 6, you're taking away 6 each time until you get to 0. And at the end, what you do is you count your groups, and that gives you your answer. So if you see here, they started with 24 because that's what they started with here in this division problem. And they take away 6, you get 18. You take away 6 again from this number, you get 12. You take away 6 and you get 6. You take away 6 one more time and you get to 0. So the goal with repeated subtraction is to take away the number until you get to 0. At the very end, you just count your groups. 1, 2, 3, 4. So 26 divided by 6, 24 divided by 6 is 4. It's just another strategy you can use to divide. Equal groups is just you have, with multiplication division, the important thing is you have to have equal groups. If not, then it's not multiplication division. So here you have 4 groups of 3. Okay, so then you move on to skip counting. You can skip count with any number. You can skip count by 2s, by 4s, by 6, and a 100 chart. You can use a 100 chart easily to skip count as well. You have your fact families. So with your fact families, you have to have the same 3 numbers. And you have fact families for addition and subtraction, but you also have fact families for multiplication and division. If you know that 2 times 8 is 16, then you also know that 16 divided by 2 is 8, or 16 divided by 8 is 2. And you can also skip count or multiply and divide on a number line. So here you see they have groups of 3. They have 4 groups of 3. And you can skip count 3, 6, 9, 12. So this represents 4 times 3 equals 12. You have 4 groups of 3. Okay, we're going to do an example problem together. Let me go ahead and read that. It says, Mr. Lee has 12 cows, 6 sheep, and 9 horses on his farm in Texas. He has 4 times as many chickens as horses. How many chickens are in Mr. Lee's farm? So when you're reading a math problem, it's a lot like reading. You have to see who your characters are, what your problem is, and how you're going to find the answer. So, and your problem is here. Don't be afraid to always go back to that problem. So we know there's 12 cows. We know there's 6 sheep and there's 9 horses. And he has 4 times, that's very important. When you have it like this, you need to rewrite it on top. That means to multiply by 4, quadruple. Has 4 times as many chickens as horses. Okay, so we have to decide what model to use. So looking back at our models that we just went over, you can decide which one you'd like to use. For this one, I think it's great to use a bar model. So let's go ahead and use a bar model just like this one. Okay, so let's go back to here. So let's see, we need to write the characters down on there. So we have cows, 12 cows. So we're gonna put here C for cows. We also have sheep. We have horses. And there's chickens. I'm gonna put a CH for chicken so we don't get confused with the cows. Okay, so I'm gonna make a bar model. Now I'm gonna draw my bars on there. Okay, so how many cows did we have? We had 12 cows. Remember, always go back. Okay, I'm gonna draw my bar for 12. 12 cows. Okay, sheep, I had 6 sheep. Go back and check that, which is exactly half of that. So that's 6 sheep. Then I had 9 horses. So that's a little bit less than 12 and a little bit more than 6. Okay, 9 horses. And he has 4 times as many chickens as horses. So chickens has to be more because it says he has 4 times as many. If something or someone has 4 times as many as something else, they have more. Their number is greater because it's 4 times as much. It's 1 times, 2 times, 3 times, 4 times. That's a lot. If I have 4 times as many markers as you, I have a lot more. Okay, so 4 times as many chickens as horses. This is called comparative language. You're comparing things. So chickens is 4 times as much as horses. Horses has 1 box of 9. Chickens has to have how many boxes of 9? 4, because it says 4 times. So 1, 2, and I'm going to go over the line a little bit. That's okay. 3, 4, and I'm going to put a 9 in each. So chickens has 4 times as many as horses. That's why I drew 4 boxes, because it's 4 times greater. Okay, my equation, I'm just going to write that out. So there's a couple ways you can do this. You can use repeated addition. Remember, that's one of the models that we just looked at. 9 plus 9 plus 9 plus 9. Or you can do 4 groups of 9, which is 4 times 9. And that equals 36, whichever way you do that. So he should have 36 chickens on there on his farm. That's 4 times as much as the horses. Justify, that just means to check. Check your work. So I know that 4 times 9 is 36, but let's go ahead and double check that. And we actually checked it over here by using repeated addition. You can use a different model to check, or you can use your fact families, which is another model. You can work backwards, go backwards. I know that 36 divided by 9 equals 4. And I check that work to make sure it's correct. Okay, so there you go. There's an example. And in this, just one example, we use a lot of models. We use equations, we use repeated addition, we use fact families, and we use a bar model. So there's a lot in just this one problem that we used. Okay, that was all for today. We'll see you next time.